Hello everyone. So today's video we will be talking about Supermesh. It consists of two mesh currents that are combined to one another because KVL cannot be used to solve for the elements that you're trying to find. So first, I'm going to make it more simple. So say that we have the circuit right here and we have to draw all of the loops. So we have one loop right here, one loop right here, one loop right here, and another one, finally, one right here. So we can solve for our KVL and for this one as well. But these two, we cannot simply do that because we have a current source. And because we have a current source, we're going to have to develop a super mesh where it's essentially this entire path. And this big loop that encompasses these two smaller loops would be called the super mesh. And let's just label what these mesh currents are first because that's a little bit important. So we'll label this as I2, label this as I3, and this one is I1 and I4. So we're going to be able to apply KVL within this big loop right here. And then these smaller loops we also have to consider. And these two smaller mesh currents are going to be in an equation with this current source. And that equation would be called the super mesh equation. In the super mesh equation, we don't use KVL, but we use KCL. In KCL, we have a node, and this node would be depicted at where this is. And then we're going to identify the incoming and exiting currents that are around this node. So we have to find out the direction at which I2 and I3 is traveling. So I2 is traveling clockwise in the left side of this node. So it is entering the node, so it's I2. And then I3 is exiting the node because it's going clockwise on the right side, or on the right of it. So it would be exiting, and it would be right here, I3. And then we have this current source right here. We can label this as lowercase I, and lowercase I would be going into the node as well. And thus our super mesh equation would simply be just I2 plus I is equal to I3. And there we have our super mesh equation. And then our KVL equation would simply be, I'll do that in our practical example, which I'm going to show you guys what it is. So I hope you guys understand what this super mesh equation is, because we're going to apply it into this example. So we have the circuit right here, and we're given all the elements of our circuit, and the question is to determine all of the mesh currents. And how do we do that? Well, first let's just draw all the loops. So we're going to draw one loop right here, label that as I1, and then the rest as follows. And very important as well, when we're trying to assign our sign convention, we're going to label our polarities for each resistors. So I'm just going to randomly do it. So now let's apply KVL first before encountering the concept of supermesh. So let's just apply KVL to I1 first, because it doesn't seem like there's a current source between its neighboring mesh. So let's just apply it from now. So that would be 1 ohms times I1 plus 2 times I1 plus 1 times I1 minus I2, and the reason why we're subtracting by I2 is because it's going from minus to plus. and that would be our first KVL equation. And we can't apply KVL to I2 or even I3 because there's a current source. Therefore, we're going to have to develop a larger loop, which is this one. So I'm just going to write this in lead pencil. So we have to apply this big loop right here. And now we are able to apply KVL to it. So let's start from this resistor, and that would be 1 times I1 minus I2, and then plus 2 volts. It's going from plus to minus, so it's just plus 2. And then we're going to 2 ohms right here, plus 2 times I3. And then we have to consider the neighboring mesh, which is I4, and I4 is traveling from minus to plus. So that would be minus I4. And that would be equal to 0. Now I4, we can apply the KVL equation to that, but we have a current source right here that is not attached to any other neighboring mesh current. Therefore, we can just state that I4 is equal to I, and therefore it equals to 2 amps. So now we've given 2 equations. Equation 1 right here, equation 2 right here. We've already given what I4 is. Now we have 3 variables and 2 equations. And we can't solve any of the mesh currents until we are able to develop another equation. And that equation would be our supermesh equation. And what is our supermesh? Well, these are our 2 sub-mesh currents of part of that big supermesh space. So we're going to have to apply the node on top. So we have that node right here, and then we're going to apply that KCL method, as I've said before. So KCL, and then we have this intersection, and then I2 is entering the node, I3 is exiting the node, and the current source is entering the node as well, and now with 7 amps. And thus our supermesh equation is going to be I2 plus 7 equals to I3. And now we were able to isolate what I3 is equal to, and that is I2 plus 7, and we can sub in I3 into equation 2. So let's just do that, shall we? So we have, I'm just going to write down equation 2. And then we know that I4 is equal to 2. And then when we factor all of these out and simplify them, we get I1 plus I2 plus 12 is equal to 0. Now our new second equation would be I1 plus I2 plus 12 is equal to 0. And our first equation, which is I1 plus 2I1 plus I1 minus I2 is equal to 0. So this is equation 1 and this is equation 2. And now we can solve either one of these 2 variables because we're already given these 2 equations. So let's just factor out this one first. So we have 4I1 is equal to I2, and then we can sub the value of I2 into here, into equation 2, and there we're going to get I1 plus 4I1 plus 12 is equal to 0. And then we get 5I1 is equal to minus 12. And I1 is going to be negative 12 divided by 5 amps. And then I2 is going to be equal to 4 times negative 12 divided by 5, and that equals to negative 48 divided by 5. And then I3, back from our supermesh equation, would be equal to I2 plus 7, so therefore negative 48 plus 5 plus 5 over 35, and that would be negative 13 over 5 amps. And there we go. We are given all of our values for each mesh current. And we did that by using Supermesh. I hope you guys enjoyed this video.